Types of solutions. That's today's lecture. A solution is a homogeneous mixture. A solvent is any substance that has other substances dissolved in it. A solute is a substance that is dissolved in a solvent. So we're looking at basic elementary science, where we dissolve something, okay, and that something that we're dissolving is called the solute. And we always dissolve a solute within a solvent to form a solution. Example of that, one of the most common ones I really like to use in the classroom is dissolving particles of salt into a beaker of water. So the salt that I'm adding in, okay, salt, water, the salt here is what we call the solute. The water is what we call the solvent. And this homogeneous mixture that is formed in the end is what's called our solution. Pure substances have a fixed composition. The ratio of atoms can never be changed. So if we look at it something like water, as we said, we know that water is always 2 hydrogen atoms combined to 1 oxygen atom. The other example that we used was salt. And the salt, we're going to look at salt in terms of NaCl, but we know as science majors that anything that is considered an ionic compound is considered a salt. So we're looking at salt in terms of sodium chloride. And we know that for everything, when we look at sodium chloride, it's composed of Na and Cl. Okay, so those are considered pure substances. Solutions, now when we combine a solute and a solvent together, solutions can have what we call a variable composition. We can have a different variable or a different ratio of a solute to solvent. So what we have here is we have an example of us forming tea. And so we can form tea and we can make it really light. So the solute that we're dissolving within the hot water is not as concentrated in here as it would be in here, forming obviously the darker composition. So we can put a little bit, or we can like really dilute it and make it a lot lighter. So what we're looking at is a different amount of solute but the same amount of solvent. So we're dissolving less into the solvent, or we could be dissolving even more into the solvent, and that will cause this variable composition. But in the end, still, if we're mixing the two things together, right, whatever is making up the solute is that pure substance. Okay. Whatever's making the solvent is yet another pure substance. And when we mix them together, whatever that ratio happens to be, that can actually be variable. So that can change. So when a solute dissolves in a solvent, it is considered a physical reaction and therefore can be separated using physical properties. Okay, so we can use things like melting point, boiling point. Right? So here we have our mixture of salt and water. So we continue to add heat to it. We cause the water to evaporate. And what are we left over within our beaker? Well, would be our salt particles. But originally, when we mixed the salt into the water, we'd get a solution. And that solution would be homogeneous. And technically, well, we couldn't really see the separation between the two. So all of it together is a solution. But the amount of solute to solvent might be different from one mixture to another. A solution can be a gas, a liquid, or a solid. So what I have here, I'm going to show you guys just really quick that we've looked at the example of the salt dissolved in the liquid. Okay, the salt dissolved in the water. So a solid dissolving in a liquid. But we can have any combination of a solid, liquid, liquid to liquid, gas to gas, gas to liquid, gas to solid. Okay, so we can have gas solutes dissolved in another gas solvent. Examples of that: air, natural gas, oxygen, acetylene mixture used in welding. We can have gas dissolved in a liquid. Example, okay, your carbonated drinks, the water in rivers, lakes that contain oxygen within them, right? So oxygen gas dissolved in the solvent, being a liquid, and gas can also be dissolved in solids, as you would find hydrogen in the metal called platinum. We have liquid can be dissolved in a gas. So we have water vapor in the air, so when temperature increases, the water that evaporates can actually make its way into, can turn into a gas form and actually dissolve in the atmosphere. Okay? Gasoline-air mixture, another example. We have liquid dissolving in another liquid, alcohol in water, antifreeze in water. So these are just a few examples that we're looking. And notice how we've got each one of the states of matter. We've got gas in a gas, gas in a liquid, gas in a solid. So we're looking at liquid in a gas, liquid in a liquid, and now liquid in a solid, as we find in amalgams such as mercury and silver. We've got solid in a gas, as in mothballs in the air. We've got solid in a liquid, as in sugar in water, the table salt in water, as we've kind of shown you guys that example at the beginning. And then we have solid within solid, as in alloys, as in the copper, nickel alloys that we make to use coins. An aqueous solution is a solution in which water is the solvent. Okay? Some liquids, such as water and ethanol, dissolve readily in each other regardless of whatever proportion you make, right? When we mix salt, well, actually think of the example of mixing sugar into your coffee. So I used to really love my coffee to be really sweet. And so what I do is I put in so much sugar to make the coffee sweet. But what's left over, imagine that cup of coffee and me getting to the very end. What's going to be at the bottom of my mug? That mug is going to have almost like a syrupy feel to it, because all the sugar that wasn't able to dissolve, because that coffee was only able to dissolve X amount of sugar. The minute I go beyond the amount that I can dissolve, it won't be able to dissolve it. Okay, so regardless of the amounts that you use of ethanol and water, they will still dissolve within one another. Now, regardless of any amount. Now, any liquids that are said to be miscible with each other, right, means that they can dissolve within one another readily this way. Liquids that cannot be done that way are called immiscible. Okay? So these are liquids that do not readily dissolve in each other. Example, most common one, water and oil. They don't mix with one another.